Um, I decided to do a video on just memoizeWith because the next several are all merge functions, like a whole bunch. And this one's pretty cool. I played with it a little bit, and I don't like their example, so I'm going to show you an example I made, and I actually have one prepared that I'll show second. Um, So for all the React babies out there, I think there's like a use memo or something. I don't use React, I use Svelte, by the way. But this is basically a function designed for caching. So if you have a time-consuming or resource-intensive process, and you have data that you can rely on being the same all the time. We use pure functions with functional programming, so we can cache the results and just return the result from the cache if it exists, and if not, then we run the expensive computation one time. So that's what memorize with does in my explanation. But let's look at it starting with the type signature. And it takes a function, it takes two functions and returns a function. So the first function takes a variadic amount of arguments of any type and it returns a string. The second function takes a variadic amount of arguments of any type and returns an A. And this gives you back a function that you can call with the same thing, the same amount of arguments of any type and return an A. So that's not all that informative just by the type signature, but it's a good general outline. Taking two functions. The second function is the same type signature as the function we're going to get back. But in more useful terms, this function is called the keygen function. It's the function to generate the cache key. So what we're going to have is this object where each value that we call a function with is going to be, we're going to generate a key for that value so that we can look it up by that key. And so that key is going to be a string because object keys are strings, unless they're an array. And then we're just going to pass it the function to memoize. So this could really be anything. This is just basically like when we call this function, I want you to remember the value we passed in and the result and store that as a key value pair in a cache object so we don't have to do it again. And then we're going to return a function, which is the memoized version of this function, right? So we're basically going to decorate a function. We're going to wrap it with the ability to cache the results of each input. Yeah. So let's read their definition. So it takes a string returning, um, oh, sorry, it takes a string returning function, which is called keygen, and a function, which we'll call fn, and returns a new function that returns the cache results from subsequent calls with the same arguments. So if I call it with a 3 and it gives me back a 9 after like an hour of calculations, and it's like, oh, finally, the answer is 9. Um, we just store that as a pair. If I give you 3, you give me back 9. Like we just remember the results. When the function is invoked, keygen is applied to the same arguments and its result becomes the cache key. If the cache contains something under that key, the function simply returns it and does not invoke the function, right? So that's the goal, is just invoke the function for one input, one time only. Otherwise, function is applied to the same arguments and its return value is cached. So this is saying that if you haven't run it before, you're going to run it and then cache the results or remember it. Care must be taken when implementing keygen to avoid key collision or if tracking references, memory leaks, and mutating arguments. So I don't really have any examples of anything other than avoiding key collisions. You'll just have to make sure that you're not generating the same key, like whatever function does to create the key, you just want to make sure that's unique every time, is what they're saying. And then there's problems with memory leaks, mutating arguments, and tracking references. I don't really know what they mean by those things, or I don't know how to demonstrate those things. But let's get into an example. Um, I'm going to make a function called double, and this function, at first, we're going to do it like this, and we're going to return x times x, right? But before we do that, or at the same time, we're going to do a log of the double function did it. So when we call this function, we'll get pass it 3, we'll get back 9, but we're also going to log the function did it so that we know that the function is running to give us back our answer. And I'll refactor this a little bit in a minute. So then we're going to use our memoize with. We're going to call something, I'm going to call it cached double because memo double looks funny when I type it. Uh, so we have our cache double, and we're just going to take our memoize with the memoize with function, put it on another line, and it takes two arguments, right? It takes the key generating function, which we need to come up with, and then the function that we want to memoize. So, let's say x for right now, and then the double function. And we will need to pass the double function to x. Can't remember, to tell you the truth. But the no, sorry. Um, all we're doing is we're decorating this double function with this memoize so it can remember everything. So now we just need our string generating function. And a really handy one is just the string constructor that's built into JavaScript. If I'm going to pass this a number, and you can pass number to string like that, and it'll give you the string 3 back. So point 3, you can make a complicated key function, but I think this demonstrates fine. So then if we log a call to cached double and we pass it 3, we get the double function did it, and then it returns 3 times 3, and we get 9 all at one time. But if we call it twice in a row, the first time it says the function did it, and we get back 9. But the second time we're getting 9 back from the cache, from this like invisible object. I wish there was a way to see it, but I don't know how you would. Guess we could put it in a pipe or something and then use tap so we could console. But what would we console? Yeah, I don't know. I don't know how you could see it, but it'd be kind of cool if you could. And so if we call it again, the first time it runs all that, the second time just this and just this. So very useful because you can just pass it any function. All you have to do is worry about how you're going to generate the key. And in a lot of cases, you can just like basically stringify it. You could do JSON.stringify, I think. That should work in just about every case, as long as you're generating unique keys. That's what they mentioned. Yeah, I mean, for here, you get the same thing, or in the console here. Yeah. So that's that version. For a more useful version, or I don't know if it's more useful, but just another version, there's a thing called a perfect number. This is something I did in Haskell, uh, just during like a beginner thing. Like I'm not a Haskell whiz or anything. I just play around with it. But a perfect number is a positive integer that is equal to the sum of its proper divisors, excluding itself. So that means if I gave it the number six, the divisors for six, like the numbers that you can divide six by, that will give you uh, that you can divide evenly by. So like six, you can divide it evenly by one, two, and three, and then itself, but we're excluding itself. So these are the three divisors of six, and if you add them together, you get six, and that's the same number as you passed in, and that makes it a perfect number. And there's not like a lot of them. Um, I mean, numbers are infinite, but they're not as common. And then another example, 28, the divisors are 1, 2, 4, 7, and 14. Add those together, you get 28, which is what you started with. So to do this, I just kind of stepped through it um, and divided things out to make it what I thought was clean. So I've got this is even binary function. And the reason I call it binary is because it takes two arguments. We're gonna pipe these two functions together, and modulo takes two arguments, and we're gonna pass them both at the same time. So that's why, like, I just wanted to be like here, you can't tell that it takes two arguments at one time because it's point free. But then this is going to take the two arguments, apply the modulo to it, and then check if that argument or that value is equal to zero. So that'll tell us if the number we pass in is uh, even, or sorry, if it doesn't, it takes two numbers and then it runs this operation, and then the result will tell us if it's even. That should be a better way to say it. But the reason I'm doing that, let's skip down to this is perfect number. I'm using the converge function, which I find really handy now that I've learned it. And it's just going to call equals with two arguments. And this function is going to return the first argument, and this function is going to return the second argument. So we're going to apply is equals to the number we pass in, and then to whatever number this function returns. But the we only need to pass one number to his perfect number, and it uses that number to come up with this value, uses that number with this function to come up with this value, then it calls equals on these two. So a perfect use case for this. Uh, but to find the sum of divisors, we're using this function here. We pass in a number. Like if I wanted to know the sum of divisors for 28, uh, I would call is perfect number with 28. N would be 28, goes to the pipe. And so we're going to make a range, an array from 1 up to 28, but actually the number before, 27. So whatever the number is, it's going to be one less. So we have an array of 1 to 27, and then we filter those numbers where each one is even, but we're looking at the number in the array, and then we're passing that, and then we're passing or sorry, we're passing the number, like the 28 here is the n, and then the number in this range we created is our x. So that's what's, in the first one, it's going to be 28 divided by 1. What's the remainder? Is that equal to 0? So this will give us a list of all the divisors, and then we sum them together, just like we do here, and that returns that number. So Yeah, so that should tell us if each thing is a perfect number. The thing is, it takes a long time, um, depending on how large a number you use, and each it takes longer to check the next number, and it keeps going. I don't know anything about time complexity, except that it exists, and this one is like definitely not performant. Uh, so it's perfect use case to memorize the result. So we just want to memorize this is perfect number function so that when we call it with a value, the next time we call it, we can just instantly get the result from the cache. So we memorize this function is perfect number, and we use the string constructor to take that value like 28 and use that as the key for the result in the cache. So if we call that number using the console.time so that we can track how long it takes to run the function. So it starts the counter here, runs the function, and then ends the counter and gives us the time back. So I'm going to go 3, 2, 1, enter, and it didn't work. Why not? Maybe I didn't save. That seems to be the common thing. 3, 2, 1. Here we go. So that took 1.880 seconds. Um, but if I do it again right afterwards, we can compare it. 3, 2, 1. That one took 1.9 seconds, and then it gave us the answer true for this large number. And you might not know, but you can put underscores in between this, and it doesn't care. Um, and yeah, and then the second time it took like 3/100ths of a second versus almost 2 seconds. So this is how you can tell it came from the cache, and this one came from the initial function call. So I started thinking about using this for doing like a fetch request and caching the results, or at least within the time someone's doing something like on the same page. If they left the page and came back, it would clear the cache or something. And doing it client side for checking the object cache on the client instead of going to the server to do something. But only like that's super dangerous, but only if you have complete control and you're the only one that messes with the back end. And in my situation, that's kind of common. Um, Now that I say it though, like that's super bad practice. But I'm just trying to come up with things that might be useful. I don't look, I don't calculate perfect numbers a lot in my day-to-day business. So yeah, so that's memoized with. And just one other little thing, like you may know this, but where was the function that I made down here? Let me, it won't matter. Yeah, here we go. Um, if we just wanted to be like real crazy about it and we didn't like the return keyword, there's something called a comma separated return. I could take this calculation here, which is an expression basically, right? X times X. And I could remove the return keyword and remove the uh, square braces and then just put a comma and stick it here. And you can see we got an error. And VS Code doesn't even like it because what we need to do is wrap this whole thing as an expression because it just doesn't know what to do with it tactically. But when I try to wrap it like this, like VS Code freaks out. But I have to do it like a Neanderthal and like actually type the character one at a time. and then it's okay. And then it's a one-liner essentially. And what it does is the rule is that the last thing after the comma is what gets returned by a function. So then you just might need to wrap something in parentheses. And when you wrap anything in parentheses in JavaScript, it turns that into an expression. So just to prove that it works, let's go back and oh, it's running that other code too. But yeah, the first function did it 9, 9, and 9. That's what these things do. So yeah, cool. Memoize with. I like it. Um, we'll pick up in another video and get into all these merge functions, which I looked at the first one. It's pretty straightforward to me, I think. Uh, thanks for spending your time with me. Tell a friend, and I'll see you in the next video.